Hello, everyone. We are back at Maker Studio. This is our season two, and this is the last episode of our season two. We're going to show you this awesome robot which we have built. And before we go into this robot, let's start with introductions. Myself, Anupam Mishra. I'm a solutions architect at AWS, and I work with a lot of customers which use AWS. So very happy to be doing this show and really enjoy what we do here.
Yeah. Hi, Todd Varland, Business Development Manager for AWS IoT. Been doing the show, what are we, 10 episodes so far this year?
Yeah, so
like
season
that?
1 and season 2.
Season 2, yeah. So we're going to, at the end of this show, we're going to talk about season 3, which will go up toward the end, almost close to reInvent. So middle November.
Yep.
Anyway, so we're here in downtown San Francisco, looking out the window at the bay.
Yeah, you might have noticed that this is looking like a different location as compared to what we have shown before.
Yeah.
What is the change, Todd? Why are we here?
So we're in the same building as our maker space, which we usually broadcast out of when we're in this building. But today we're on the 21st floor, the top floor of our downtown San Francisco office, because we're trying out basically a new mechanism for broadcasting the show using our own internal video conference system. And the reason that this is important is because we did this last episode from San Francisco or from Seattle, and we're doing it this week from San Francisco. And we're proving out the idea, which means that many more people around Amazon can produce content and not have to purchase their own kind of camera and video production equipment. So
yeah,
that's what we're testing out. So this is another yet another live experiment. So
yeah, and we love experiments.
Yeah. So yeah, this is going to set us up so that the folks in Amazon and AWS, we can deliver content across more topics and more teams.
Yeah, it was a lot of hard work which we had to do to get the initial set of equipment set up. We are very happy that now we can use some of the generic things which are available to us. Yeah. So very happy to be using that. Yeah. Now let's jump into what we are gonna do, what this show is and what we are gonna do today. Yeah. So this show is to inspire and educate people about building something which you always wanted to build. So it's not about us telling you how to do certain things. It's more about what do you want to build and interact with us, and we shape whatever we are building based on your feedback. So far it has been awesome. We've heard great things about what people get from this show. We go all the way from assembling hardware to building a lot of software, how to connect cables, what chip is used, where does Raspberry Pi works, what kind of speakers we use, so many things, 3D printing things. Yeah. And this specific season is focused on artificial intelligence enabled robots. So what does that mean, Todd? Let's talk a little bit more about that.
So our the challenge that we set for ourselves maybe 5 or 6 weeks ago was to build a robot that we could give it voice commands. It would understand those commands. It would echo back responses with voice messages, and then it would act on the commands that we gave it in using image recognition and robotics and 3D printed robot arm to carry out our wishes. So
nice.
our subservient robot.
Yeah. So let's put it to action. Let's see what it does. So we first want to show you how it works, and we're gonna show you what.
Let's go through kind of the pieces and the parts. So we've got 2 blocks here. Here, you hold this one. I'll hold this one. So we've got 2 just 3D printed cubes, and we have a picture taped on the front. This one is, if you can see, it's Jeff.
And this
Bezos,
is Andy Jassy.
So we basically put these blocks here, and then we've got a 3D. We're gonna put this all up hosted somewhere, probably on GitHub. But we have a 3D printed robot arm. This was a continuation of the robot arm that we used for the mini fulfillment center demo that we did at reInvent in December 2016. So it's got a Raspberry Pi. We have an external speaker. And then we have, as we've continued through this episode or this season, We have a Seed Studio Respeaker hat, which is a far field microphone and audio out. We have a Pi camera. We have this end effector. We're using Dynamixel servos from Robotis. And I think those are and then some Python code.
So I think right now it's cabled together, so we are not moving it. But let us show the demo, and then we can show them what pieces are here.
Yeah,
we're a little bit closer to the camera.
Yeah,
sure. So
and then the Amazon pieces and parts are.
Yeah, so there are 3 services we are using. One is called Lex. Lex is the one which allows you to talk to a machine or any input source. It could be audio, it could be text, and then it understands the context in whatever you're saying. So you can build chatbots, you can build interactive interfaces, which are where people are talking in the natural way, and then the system can understand what they are talking. So that is Lex. Then we have another one called Recognition. Recognition is the one which takes a photo as an input, and it can find out a lot of things about those photos. So the last episode of our season was focused on recognition. We bought a lot of photos there. We bought some of Todd's favorite celebrities like Jennifer Aniston, and we had a few more, Tom Cruise and others. And we showed like how it can recognize people, and it can also tell where those people are in the photo. So that's a very important thing, because when this is taking a photo, we need to know where Andy Jassy is and where to send this robot to pick the cube where his photo is. So we are using that functionality for it. And the last piece is Poly. Poly allows you to let computers speak whatever you want them to speak. So think of it as a text to audio or text to speech. And you can decide how a specific thing should be spoken. It gives you a lot of power in terms of how slow that should be, what kind of voice it should be, where should it pause, how to spell, how to talk about a phone number, and a lot of other languages it can support.
Yeah, there is another piece, and I'll show the website when I share my screen. But one of our colleagues, Brett Francis, wrote a Python library called Servode that gives really clean and easy access to the Dynamixel servos directly from Python, yep. and it has a command line interface. So anyway, Brett wrote that last year, so kudos to Brett. So we're incorporating that. That made, again, just the development process that much easier.
So let's show everybody how that works later. Let's start with the demo.
Yep.
Do you want to kick it off, Todd?
Yeah, so I'm going to go ahead and start our Python application and go ahead and get it started.
Jarvis, pick up Jeff Bezos.
And then on the screen, it's taking...
So it's taking a photo right now. Let's see whether it can take a photo and detect whether...
Right. It's sending it to recognition.
Okay, let's see what it does. Okay, so it thinks the cube is there.
I found 2 celebrities in front of me. Their names are Jeff Bezos, Andy Jassy. I just picked Jeff Bezos as you asked me. Shall I put his back on left or...
Put it on the right.
That was fun. Let's play.
So let's stop the program. I just want to tell everybody what just happened.
Yeah.
I was talking to the robot and told it that pick up a specific person, and then it tries to take a photo and checks whether that person is on this frame or not, based on the camera. And then it takes a photo, and from the photo it finds, oh, this person was talking about Jeff Bezos, and Jeff Bezos' photo is on this, and it tries to find the location of it, and then it goes there and grabs it. And then I don't know if you were able to hear the sound. We have a speaker which we thought will be very, very loud, but it's not as loud as we thought. But it said, I just picked up Jeff Bezos, and it told about other people who are on this frame. And finally it tells whether I should put it back on left or right, and we tell where to put it back. So it's very simple, but it can be very powerful in a lot of use cases. So we'll talk about that, but let's do the demo once more, where we can show people what's happening on our screen
All
when this
so
runs.
We'll share my screen up there. Okay, fantastic. All right, so we'll run it so that way folks can see the command line as it's going by. So should we do Andy this time?
Just go for it. Yeah, let's
All right,
try Andy Jassy.
Cool. All right, so I start it, and this error message, it's not that big a deal. It can be ignored. Oops, talking. I accidentally activated it. Let's try that again. All right. Jarvis, pick up Andy Jassy.
It's taking a photo and sending it to recognition.
I found two celebrities in front of me. Their names are Jeff Bezos, Andy Jassy. I just picked Andy Jassy as you asked me. Shall I put his back on left or
Put it on the left.
fun?
So another awesome thing done by our robot. So now, I mean, it's pretty fun, at least for what we are showing.
Yeah.
But possibilities are, like we were thinking, there could be games people can make out of it. People can do sorting. Or what?
I mean, you could do all kinds of things, and so I mean, obviously the inspiration here is Jarvis from Iron Man. So really, I mean, this is super simple, but this could be extended to do lots of different things. So I'm just thinking about things I want to do in my man cave. Have it like, I don't know, close the blinds, or I don't know, maybe mix me a cocktail, or I don't know, something.
Yeah, that's very interesting because one of the things we are thinking is how do we take it to next level? And one of the things we talked was, right now this is a stationary robot, which means things have to be in front of it. What if this guy can move around the home and do certain things? So we have a new thing we want to show you.
So
this is iRobot Create 2. And this is something which we just got from our friends at iRobot. I want to say thanks to Ben, who works in iRobot, and he sent us this kit for building this robot movable. So what we're gonna do next is we're gonna put this robot on top of our iRobot Create, and then we're gonna give it commands, and it'll move around and then find things.
And we'll put some battery packs. So it'll communicate wirelessly with the internet. We'll put battery packs so that it doesn't have to be tethered. So we'll have a even more autonomous, self-aware robot, somewhat self-aware. So
one of the things people asked us in one of our earlier episodes was, can the Twitch chat control your robot? Like we will say something, and can your robot do it? I think it'll be a lot of fun when that robot can move around in a specific room, and Twitch chat can tell it what it should do.
Yeah. So the idea here is that we'll open up a live Twitch session, and then we'll set things up so that folks can type commands into the Twitch chat window to steer basically the robot and tell it to pick things up or drop things or what have you.
Because we can put a camera on top of this, people can see what the robot is looking at, and they can say, I want to pick that banana, I want to pick that apple, or it could be objects.
Yeah.
And then hopefully this robot will understand all that.
Yeah.
So a lot of exciting things coming up. We're going to work on that piece over the next few weeks.
Yeah.
And build it in front of you, to just show you how it can be built.
And so season 3, so talking about kind of when this is going to come into play. So we're going to take a break for the month of September, and then restart again in October. And during that October timeframe is we're going to bring in other folks to work on these projects, and also bring in their projects that relate to these things.
Yeah, that's an interesting thing actually. Yeah. So far what we have done in Maker Studio is the first season was all about how robots work, and how can you have cloud controlled robots, like having them connect to cloud, and you can have cloud do all the intelligent stuff. This was focused on artificial intelligence. How can you make them hear things? How can you make them see things? and talk about,
say things,
say things and talk about them.
Yeah.
So now that we have seen those two pieces, we are thinking that a lot of people would create some useful things either in their home or workplace or wherever they see a opportunity, and they will share with us.
Yeah.
We have seen a lot of interest in that area, so hopefully we'll see more projects shared with us. If you have something interesting, share with on this LES. We have an email address called aws-twitch@amazon.com. So if you just send an email to aws-twitch@amazon.com, we will get it, and we would love to know what you're building, and hopefully have you share whatever you have built with the rest of the community out here.
Yeah. And maybe we'll have you. We'll showcase some projects live on the show.
Yeah, we are looking forward to our season 3, where we have a lot more contribution from the community and the projects which people have built. We're going to start with this iRobot create, and let's see where it goes.
Yeah. All right. So should we show some code?
Yeah, let's jump into some code actually. So before we jump into code, I wanted to show something on your screen, Todd.
Yeah, which thing?
So just scroll up here. I wanted to show what happened. There are a bunch of things. I just wanted to show because it was just going so fast.
Yeah.
It's interesting to see what is happening in the background. So this is the first piece where we are saying Snowboy keyword detected, which means Todd just said Jarvis, and it understood it's a word which I care about, and as soon as it learned about that word, it's almost like an event which it triggers.
Yeah. So we in our first episode of this season, we walked through Snowboy from Kit AI and its local wake word on the Raspberry Pi that triggers basically any code you want. In this case, it's Python code.
Yep. So in this case, it gave us a trigger. We knew that now is the time to act on whatever the person is saying, because we ignore anything which is spoken without a hot word. So as soon as that hot word comes, we start listening and start acting on this. Now, for listening to what user is saying, we are using a library called SOX. It allows us to record an audio given a time duration. So in this case, we are recording for 5 seconds. We are assuming that whatever command user has to give, they will give in 5 seconds, and we'll record an audio out of it. So for that piece, we have a specific device here for recording. What was that, Todd?
Seed Studio Respeaker. So it's $10. It's a far-field array. We use that because otherwise you have to push a button or activate the sequence in some way. This way you can literally I'm gonna add one of these to my car. I'm gonna take a Raspberry Pi Zero with one of these respeakers. So a $5 Raspberry Pi, a $10 hat, and a USB connection, and kind of probably a Bluetooth dongle, and I'm going to put it in my car and basically have
talk to
my car and read info from the onboard diagnostic bus from my car.
A lot of use cases given that the cost of these hardware has come so down. It's probably very easy for a lot of people to make whatever they want to make.
Exactly.
And with cloud, you don't need all the hard work done on these devices. You don't need to learn how artificial intelligence works for a lot of use cases. Like for building this speech interface, I don't have to learn how a specific user speaks. The models which Amazon has are already trained for different types of voices. So get a lot of stuff can be built so fast.
Code that we wrote, what would you estimate all in?
I would say it would be probably 100 lines of code in terms of what we wrote, probably less than that, because a lot of it is glue code where we are typing things like this. Okay, time to speak, time to log out. I'm going to walk you through that so you get a good idea of how this is working. And that's the core purpose of this show. We wanted to avoid any hand waving and show you the real stuff of how things are working end to end. So now that we have seen there's a recording happening here, once the recording is done, we just print done and send it to Lex. So we send an audio file which we had just recorded to Lex, and then Lex returns us this big blurb. Now I'm highlighting that blurb. So Lex is telling us that I just got a request ID, and then somebody spoke this thing. So if you look at the transcript here. Let me highlight that piece because that's very important to know how it works. So there's a transcript, Lex input transcript, which means what are the words which Lex heard when somebody was speaking. So it heard somebody say pick up Andy Jassy, which is great. So it heard that thing, and then we have a bot which we have created. We talked about how to create the bot in our episode 2, which we broadcasted from New York Summit.
Yeah.
So if you want to see how to build a bot, we'll show you. You can watch it out. If we have time, we'll show you today.
You can binge watch all of our shows and learn exactly how to build this.
Yeah, but we'll try to at least show you the screens if possible, if we don't run out of time. But so this is the input transcript, and then it tells you the answer. So there's something called slot, which means the variables which we're interested in, and it's telling that name was identified as Andy Jassy. So from the words which were spoken, it found that we are interested in Andy Jassy, and it returned us that. And then we are printing that name of the celebrity is Andy Jassy. And then we say, now that we know who to pick up, who is the interested person, like who is the person we want to pick up, then it takes a photo and says, I'm taking a photo. Then it takes a photo, it's sending it to recognition now. So recognition is the service which is recognizing objects or celebrities. So finally we find it and we say location is this. This is the place where we want to go, and we are looking for the nose of the person because nose is the center of this cube or on a given plane. So we thought it'll be easier for us to just focus on that, but you can pick up anything else. You can say where is the person's eyes, where is his mouth or anything else. And then we are printing what was found. So we are saying Jeff's nose is at this location. Jesse's nose is at this location, and then we are making some bunch of calls to the servo library, which Todd talked about.
So let's switch to that for a second. So this is the GitHub servo. So this is so Brett open sourced this, and so anyway, so this is the library that makes it super easy to access the Dynamixel servos.
Yeah, so we'll share the link for all the resources we are using in our resources section. But for now, you can think that there's a library which makes it super easy for us to talk to these motors. Mm-hmm. And we are telling each of the motor to go to a specific location right now, based on which one we wanted to pick up. And then once the pickup is done, it says picked up, and it says found 2 celebrities and what were their names. And finally, it does another recording because it's telling us, it's asking us, should I put it back left or right? So it again starts recording a new voice, and that voice is recorded using SOX. And finally, it is sent it back to the Lex. And this time, as you can notice, the words which were spoken were put it on the left. And it found from this, the interesting thing is direction, which is left. This is all programmed in a bot. It's super easy. And then it tells it's left. And then because it's left, it tells the servos to go to the left location and leave the block there. And finally, it says, that was fun, let's play again. So, I mean, you can do as much fun as you want with this thing, but I just wanted to walk you through what happened in the background while this was working. Now, let's go into the actual code. So, let's switch to another laptop. I'm just showing my laptop this time. Okay. Awesome. So let's go through the core pieces as we talk. There are like 4 or 5 core pieces here. Lex is one, recognition is one, Poly is one. Those are the AI services we use. Then Snowboy is another one, which is detecting when a specific word is spoken. And the last one is how to control motors. So that's the 5th one. So let's start with one of them. How about we start with Lex?
Oh, and then there's also the Blink code is in there as well.
So we are not going to show the Blink code. So we had a placeholder code, and this is an interesting story. I think we should tell it.
Yeah, sure.
So when we started this series, we were not sure what we will be building. We thought like the robot should be able to hear, should be able to see, should be able to talk, but we don't know what is a good, interesting use case to show that. And we thought, let's take baby steps. So we thought the first baby step was Blinker.
Yeah, so this Seed Studio hat has an LED array on it, and so we just voice activated making the lights blink however many times, and that we used Lex. So that was our first episode.
First episode was just blinking, and then we thought in the second episode we thought let's focus on recognition, and we had a bunch of celebrities on this ground, and we were holding this arm by hand and asking it to detect which celebrity it has. So that was part 2. So we had voice figured out, we have recognition figured out, and then we thought, let's tie everything together and see how it works. So this is our final episode where everything came together. We're pretty happy with how it came together.
Yeah, we did a lot of work in the last 6 days.
We were like hacking on the go. So let's start with the full program. I want to show you the high level structure first, without going too much into details. So I think the first thing is there's a Snowbyte decoder. We're just using a library which is available. I think it's available on GitHub. There are specific kind of license agreements. It's good to check them based on what kind of use you have. And then once the word is detected, we call a function called detected callback. So let's go there. This is where all the interesting stuff happens. So we say, hey, now that you have detected something, stop detecting anymore, because we know something has been detected.
Yeah.
And then we print, yes, how may I help you, just for us to know that, okay, now we are in the function. And then we are calling a function called callLex. So think of it as a function which records an audio and sends that audio to a specific bot which has been built. So everything is done in this function. I'm going to show you that function later, but right now think that Lex calling is happening here, a recording is happening here, and it tells you what was returned by the Lex. So now Lex result knows what was returned, and it returns the name of the celebrity. So it tells us the celebrity was detected as whoever the name is. So now that we have celebrity name, what we do is we use this program called Recipe Stills. What is that one, Todd?
Yeah, so we took a couple shortcuts along the way, just for time's sake. So we're just using basically a Raspberry Pi, Debian Linux command that's an app that we installed called Recipe Still, just to grab a still image. So we cheated a little bit here just for speed's sake. I mean, if we were refactoring, we'd probably bring this all into pure Python. And
we can have a SDK or something else.
Use PyImage or something like that.
Yep.
So this was just kind of quite frankly a convenience, but it just basically takes a still image and puts it in the location that's specified by that output option.
Yeah. So once this program runs, it's an outbound OS call. It takes an image and stores it in image.jpg. Mm-hmm. And we are storing the same file name in image_filename. Yeah. So what happens is now we are reading that file, and then we are sending that file as a byte, as a series of bytes to the recognition client. So if you look at recognition,
so that's the meat of calling recognition.
Yeah, let me make it slightly smaller font. Okay, this is all the command. So this is where you just call the recognition using just a single line. I'm calling a function named recognize celebrities. It takes the bytes of all the image which I just read, and then it's telling us a response.
Yeah, so this is actually really interesting because so recently we bought an Echo Show.
Yep.
Of course. We brought 2 of them on Prime Day. We got them on special.
Yep.
And one of the things is we bought these Netgear Arlo cameras for putting around
for security cameras.
Security cameras. So they're wireless and they operate off of batteries, and they're really quite good. And so one of the things I want to see if I can wire up at some point is grabbing images from the security cameras that are like pointed at the yard, and then use recognition to see if I can identify like the neighbor's dog that comes onto my lawn, or
you can send an alert, the neighbor is coming to our home.
Yeah, exactly. So, or the mailman's here, or whatever. So anyway, those are just some ideas. So there's lots of different potential uses, and so just seeing how easy recognition is kind of has me thinking about some different ideas.
Yeah. So what happens after you send the image to recognition is it sends you a JSON payload back, and that includes a lot of information about what recognition found in that photo. So you can have like a lot of celebrities here. So we tried with 4 in the last episode. It worked fine. And then it will tell you about what the name of those celebrities are, what is the IMDb link for them, where they're.
So it basically returns a whole JSON blob back
for each celebrity. So you can think of it as a JSON, which is an array, and then array has as many celebrities it found. So it can be a bigger blob. Sometimes it could be smaller, depending on how many people were in that photo. And then once we have the photos, we created a function called find nose position. So from that big blob, we wanted to find where is the nose, because that's the only piece we are interested in for this use case.
Yeah.
So we are saying
center of the block.
So in this case, we hard-coded name of Jeff and Andy because we wanted to make it simple as a use case. But you can imagine that if we have some other celebrity, we'll just put that celebrity's name as a parameter rather than, and that parameter can come from Lex, because Lex already knew it's Jeff Bezos, so we don't need to hardcode this, but we are just doing for the sake of simplicity. Now, once we have Jeff and Andy Jesse's nose, we check which one to pick up. So from the result which we got from Lex, we are checking whatever the person was asking from Lex, is it Jeff Bezos? If it is, then the location we want to pick up is Jeff Nose. If it is not the Jeff Bezos which was being asked by the Lex voice, we have to pick up Andy Jassy. Now this is overly simplistic, just to make it easy to understand and digestible in a short amount of time. But you can make it as generic as you want. And we are doing this lowercase just for making it take care of some edge cases where some of the cases could be lower. Finally, we say this is the location we are interested in. Now, we don't care about what was said. We don't care about what was found. Now we know this is the location, and now we need to deal with just this location. And if the location is not found, we just say we could not find the person you are asking us for, and we just disconnect. So finally, we do some debugging statements here. Jeff's nose was at this location, Andy Jesse's nose was at this location, and then finally we check what was the location we were interested in, because these two blocks were on the two sides of the frame. So we do have this is another shortcut we took. I think we should talk about that.
Yeah.
Right now we are hard coding it to two locations. For example, should we go to the left location or should we go to the right location? They're like two functions, as you can see, pick up left and pick up right. Depending on the location happens to be on the left quadrant. Let's say we call it quadrants, or let's say two sections. Is it in the left section or right section? We either go to pick the left object or right object. But this can be generic. Like this is something which Todd and Brett did in their mini.
So in the demo that Brett and I put together last December for reInvent, is these blocks would tumble off of a conveyor belt to kind of any random location. But given that we only had 6 days to put this together, we decided just to go simple.
Yeah, and how does it work? So what it does, it has a photo. It knows the location. Yeah. You just need to design what kind of movements all these motors should be doing to reach that location.
Yeah, and this is where the real benefit of higher end servos come into play. And so in our previous season, we did an episode with somebody from Robotis. Each one of these servos, think about it as it's a microcontroller itself. And so not only can you issue it commands like go to a particular location, but you can also take the arm, put it in a location, and read back the servo location. So the communication capabilities are bi-directional. And so it makes it easier to kind of train your robot so that you can figure out, okay, what are the kind of what are the physical operation space that the robot is in, and if I stretch all the way out to the corner, what are the various kind of degrees of rotation of each of the servos, and so it makes it a lot easier than just hobby servos, which are only one direction.
Yep. Yeah. So now let's get back to the code. So we know pick up left and pick up right, right? We go into those functions, and I'll show you those functions. And then finally it says I picked it up. We are not detecting whether it's really picked it up. So as you can catch, we just say if the previous steps were done, we are assuming it must have picked it up. Some people do some weight detection. They can check whether the object is really in front of it.
So this actually goes back to the bidirectional nature. So you can squeeze down on the cube, and one of the values that you can read from the servo is the amount of torque that's being exerted. So you can tell if something's being grabbed, and so it's actually pretty cool. So
you try to squeeze it and say, "Oh, I'm getting a lot of torque, so probably something is in between my hands."
Yeah. So and these are relatively inexpensive servos. These are about $50 each. But you can. The cool thing with what we've shown here is you can scale all the way up to many hundreds of thousands of dollar robot system with similar communication servos from Robotis, but the individual servos might be like 3,000.
Yeah, I've seen there are some industrial motors.
Yeah, very high precision, many more features, and so think that the way to think about this is you can scale this up to something that could be used in an industrial setting.
Well, I saw actually when we were at RoboCup, which is our first episode of this season. Yeah. We went to Japan, and we talked to a team from Australia. They were using that high-end Robotis motor, and that was like $3,000 motor.
Weren't they the winners?
They were the winners as well.
Yeah.
So maybe the motor was the magic, but their robot was very unique. So I think. As Todd said, there are a lot of controls which you have, and I think you can make this program much more robust and much more industry scale by checking those parameters.
Yeah.
Now let's go to the final pieces of this. So once the things were picked up, we just talk about what was just picked up, and then this is the command where we call polyspeak, and we just give it what it needs to speak, and finally once it speaks, we wait for another Lex call. We assume that somebody will tell us whether to put it left or right. If somebody tells left, we drop it on the left side, otherwise drop it on the right side. And then finally it says, that was fun, let's play again. So let me quickly show you the command, the functions which I didn't show you earlier. Let's start with here. Pick up left, pick up right, drop, and arm ready. These are all shell files which you have written, which are calling series of commands to tell these motors where they should be moving. So we have created so for example, pick up left, we'll tell it first you need to go forward, this motor needs to move left, right, and then what a pickup action means.
Sure.
And then call Lex, this is where we record the stuff. So again, we are making a system call just to make things easy to do. We are recording a file, and we are asking it to record in a file named hello.wave and keep it as a 5-second duration. And then we send that file to post content. Let's look at this full command. Let me quick put enter here and then enter here. So it takes the bot name, the bot which we have, what is the alias of that bot, which user is calling it, what is the audio type, what is the type of the audio, and finally the stream which we just recorded. And based on the response, we check whether there was a name found in it. If name was found, we return the name back. If there was a direction found in it, it returns the direction, and otherwise it returns none. So as you can see, the same bot can do a lot of things, and these things are called intents. So there are two intents in this robot. One is detect a celebrity, like it tells what is the name of the celebrity. The other intent is detect the direction in which the person needs to drop this. So we have two intents, and based on which intent is active in this specific thing, we return it. Polyspeak is very, very simple. we just get a text which we have encoded as we can put some tags which help in telling how the speech should come out. And then we say just synthesize speech with we want an MP3 to come out of this, and which voice ID you want. We were like using Justin just because it sounds a little bit fun. So we thought let's use it. And then we store that MP3 in we open that MP3 file and we just play it. We play it using a command called madplay. And finally, the nose position. This is very simple. There's nothing magical here. We are just parsing the JSON and looking for the nose of a specific person. So when you say find nose position, we detect the name of the person. For each name we found, we check where is their nose, and whenever we find their nose, we just return it. So somebody tells us the name of celebrity, and we tell us the nose of that celebrity if found. Otherwise, we return a none. So this is awesome. And everything else we already discussed. So, I mean, I think we did a quick walkthrough of all this code, but as you can see, it's not a lot of work. I mean, if you want to build it, probably it'll take a day or so.
Yeah.
If you just follow whatever we have.
Yeah.
Now, where will we share this? So I was thinking GitHub.
Yeah, sure.
So we have a page on AWS. We call it our homepage, our landing page. It's aws.amazon.com/Twitch. And if you go there, there are a lot of there are 3 or 4 shows we are doing now. Like we started with the live coding and Maker Studio. We have started a bunch of more new shows now. So if you go there, you can find out Maker Studio as one of the shows, and we put a lot of resources there. So we'll put something about how you can follow. Mm-hmm. So for season 2, this is our last episode of season 2.
It is, yes.
So can we go to the full screen again? Let's talk about what people should expect in season 3 of our show. Mm-hmm. So let me remove the sharing. Okay. So what are you looking forward to in season 3, Todd?
Yeah. So season 3 is going to start in early October, and then run for, I think 6 episodes. So 6 weeks. So every Wednesday at 4:30 p.m. Pacific time, and that'll go right before Thanksgiving, I think. Is that?
Yeah, so our reInvent is right after Thanksgiving.
Yeah.
So it's the last week of November.
Yeah.
And
so we're going to maybe do a bonus episode. We're going to do a bonus episode.
We were thinking that reInvent, we have a lot of people, like thousands of people across the world who come to reInvent, and we were thinking we'll just do
for folks that don't know, reInvent is the AWS annual user conference. Usually happens the last week of November, right after Thanksgiving, held in Las Vegas, and I think we're expecting somewhere between 30 and 40,000 attendees. Something I've heard. I don't know. I'm not
it keeps increasing every year. So,
but yeah, we're going to do a bonus episode from reInvent, so that'll be actually 7 episodes in season 3. But what we're thinking about is, like Anupam said earlier, is we want to bring the community into these shows, and so we've got Ben from iRobot that we're going to have on an episode. We have some colleagues from one of our data center engineering teams that are going to do some interesting things maybe about an internet connected barbecue / smoker. I don't know. We'll see what they come up with. There's other teams that we're talking to both inside and outside of Amazon to basically showcase their projects and how they're making cloud connected things and doing interesting kind of fun projects.
Yeah,
so it's really so season 3 is about the community.
Yeah, I mean, I'm thinking it will be a variety show kind of thing, like a lot of stuff. Some episodes we are hacking on a iRobot create, some we are going deep into control systems, how the motors get controlled, how they are built, and like thinking of some outside the box ideas.
Yeah.
So looking forward to it.
Yeah, so I just want to kind of re-point there. I don't know if it's easy to see, but up on the board we've got, so the way to send us information about your project that you may want to showcase or make, do a shout out about is aws-twitch@amazon.com. So drop us a note. We'd also love feedback. We'd also love to have suggestions about, future episodes, ideas, things that you'd like to see us do, things that you like, things you'd like to see us change. So anyway.
Yeah, and I think another way of sharing your ideas and suggestions with us is go to Twitter, and my handle is Ask Anupam, ASKANUPAM, and Todd's is Todd Varland.
Just Todd Varland, no spaces, no dot, no, just Todd Varland.
Yeah, just reply to us or send us some comments. We would love to hear about what you feel about the show, what are the things you would like to see, and if you have some ideas about any participation in the season 3, because we want to highlight what people are doing across the world using different AWS services. So, it's the maker world. Huh?
Yeah. All right. So
awesome.
I think that's it for season 2 for Maker Studio. So
anyway. I think we had a lot of fun. We were thinking of this as a hackathon, which we are doing, 2 of us hacking together to build something interesting. Yeah. But for season 3, we are looking forward to seeing a much bigger and variety of impact coming from people like you who are watching. So looking forward to it. Thanks a lot for watching our show.
Yeah. So live from San Francisco, it's
Anupam Mishra and it's
Todd Varland and the Maker Studio. So signing off. Thank you.
Thank you.
So shall we turn around?